There is a machine that has been at the top of its category for more than 50 years. Not unchanged. It has been continuously developed, every variant more capable than the last, every generation incorporating the lessons of the previous one. But recognizably the same machine, the same fundamental architecture, the same engineering philosophy, the same commitment to being the standard against which every competitor must measure itself. The Caterpillar D11 is the largest bulldozer in Caterpillar's current production lineup. It is not the largest bulldozer ever built, but it is the most commercially successful large bulldozer in the history of the category. More D11s have been sold than any comparable machine from any competitor. More D11s are operating in mines, quarries, and construction sites around the world right now than any other large bulldozer. The engineering evolution that produced the current D11 T2 from the original D11 of the early 1970s is an instructive story of continuous improvement. The D11 was introduced in the early 1970s as the successor to the D10, itself the largest bulldozer Caterpillar had built to that point. The development philosophy was consistent. Take the previous generation's design, understand its limitations, and engineer the next generation to address them. Incremental improvement, continuous refinement, no revolutionary redesigns, just better, generation after generation. But before we get into the engineering specifics, the engine, transmission, blade, and undercarriage, we must understand the commercial dominance, because engineering quality alone does not explain it. Some competitors have machines that are in many ways more impressive achievements. The Liebherr PR776 and the Komatsu D575A are competitive machines. Yet the D11 outsells all of them in the large bulldozer category. The engineering is part of the explanation. The full explanation requires understanding Caterpillar's distribution and service strategy as well. This is where things get interesting. The D11's commercial dominance is not just a story about engineering. It is a story of excellent engineering meeting the world's best dealer network and the most comprehensive parts supply chain. The combination produces market dominance that engineering alone cannot create, and that competitors cannot easily overcome. But the current D11 T2 is significantly more capable than the D11 of 50 years ago, not just in raw performance. It excels in fuel efficiency, electronic integration, autonomous capability, and maintenance cost profile. The continuous development investment made over 5 decades has produced a machine that is far more than the sum of its improvements. Understanding how those improvements accumulated is key to why the platform remains competitive today. The current Caterpillar D11 T2 has an operating weight of approximately 115 to 56 kilograms, approximately 115 metric tons. This weight is in its standard configuration with the standard SU blade. This is substantially lighter than the Komatsu D575A's 152,600 kilograms, reflecting the D11's positioning as a large production bulldozer. The D11 serves as a high production machine rather than the ultra-large specialized machine that the D575A represents. The D11's weight class defines its application range. Machines in the 100 to 120-ton class are appropriate for mining and construction applications. The blade, in its standard SU configuration, has a width of approximately 6.2 meters and a height of approximately 2.5 meters. The U-shape of the SU blade increases capacity by containing material more effectively than a straight blade would. The full blade capacity in the SU configuration is approximately 37.8 cubic meters, substantial, though less than the D575A's 69 cubic meters. For the applications where the D11 is most commonly deployed, the blade capacity is well matched to material volumes and machine cycle requirements. The D11 T2 is powered by a Caterpillar C32 diesel engine producing 850 net horsepower. The C32 is a well-established engine in the Caterpillar lineup, widely supported by the dealer network and field reliability records. Caterpillar's philosophy of using proven components where possible ensures reliability benefits that outweigh the advantages of purpose-designed units. The powertrain of the D11T2 uses a Caterpillar powershift transmission, shifting under load without manual clutch and brake sequences. The powershift transmission allows the operator to focus on blade management and ground engagement rather than powertrain management. The crawler system uses sealed and lubricated track links, supporting the D11T2 and providing its immense traction. Track shoes are available in multiple widths: wider shoes for soft ground conditions and narrower shoes for hard rock applications. Managing track shoe selection for specific ground conditions is part of the operational optimization performed by maintenance teams. The D11T2's single shank ripper at the rear is sized and positioned perfectly for the machine's weight and power. The ripper penetrates compacted material using machine weight and hydraulic force, breaking the material into pieces the blade can push. Ripper productivity is a function of material hardness, machine weight, ripper geometry, and the operator's technique. In applications requiring ripping, the ripper's productivity determines the overall machine productivity. One of the most significant improvements was the introduction of Cat grade and slope technology using GPS and inertial measurement. This technology allows the D11T2 to maintain precise blade position and grade control automatically. It transforms the D11 from a machine dependent on operator skill to one supported by automated blade control. The Cat grade and slope system on the D11T2 uses GPS positioning and inertial measurement to determine the machine's position and blade orientation. The system compares the current blade position to the target grade, specified by the project's design data loaded into the machine's control system, and it automatically adjusts the blade height and cross slope to maintain the target. The operator controls the machine's travel direction and speed. The system manages the blade position. This automation does not eliminate the operator's role. The D11T2 is not an autonomous machine. It requires an operator in the cab who makes the fundamental decisions about machine positioning, travel direction, and when to push, versus when to back away from the material. But by automating the blade position management, the system removes the most cognitively demanding element of bulldozer operation: the continuous fine adjustment of blade height and angle that determines grade accuracy from the operator's immediate attention. The operator can focus on machine positioning and productivity. The system ensures that the blade is in the right place. The productivity improvement from this automation is significant. Studies comparing D11 operation with and without the system show improvements in cycle time, grade accuracy, and pass count. The number of times the machine must traverse a surface to achieve the target grade translate into meaningful reductions in fuel consumption. Fewer passes means less fuel. Less fuel means lower operating cost. And lower operating cost, accumulated over the D11T2's operating life, means a better total cost of ownership. The grade accuracy improvement is particularly valuable in applications where the finished surface must meet specific engineering tolerances: mine haul road construction, embankment shaping, and dam construction. Manual bulldozer operation achieves grade accuracy limited by the operator's ability to perceive and respond to deviations from target. Automated blade control achieves grade accuracy limited by the GPS and inertial measurement system's precision, which is significantly better than the best human operator can consistently achieve. The result is a finished surface that meets tighter tolerances and requires fewer remediation passes. The D11T2 also features Cat's Link Telematics system, the same system family as the ComTrax Plus used in Komatsu equipment. Machine health data, location, fuel consumption, and productivity metrics are transmitted continuously to fleet management systems. The predictive maintenance capability identifies developing issues before they cause failures. Caterpillar's implementation reflects similar engineering discipline applied to an extensive installed base. What happened when Caterpillar first introduced automated blade control on large bulldozers was a market response that exceeded expectations. The productivity improvement was real and consistent in Caterpillar's own testing and in independent evaluations by mines. And the grade accuracy improvement opened applications for large bulldozers that had previously required smaller, more maneuverable machines. applications where the large machine's productivity advantage had previously been offset by its grade accuracy limitations. The technology expanded the D11's applicable market while simultaneously improving its economics in existing applications. That combination, expanded market plus improved economics, is the most powerful outcome a technology introduction can produce, and it accelerated the D11T2's market position at a time when competitors were developing alternatives that might otherwise have eroded it. The Cat D11T2 is deployed across a wider range of applications than any other machine in this series. Unlike ultra-large excavators, the D11 is used in surface mines, quarries, highway construction, dam projects, and large-scale earth moving. This breadth of application is a commercial strength. The market for D11 class bulldozers is larger than for any ultra-class machine. In coal mining, the machine performs dump shaping, haul road construction, overburden management, and coal stockpile management. The D11's blade capacity and force are perfectly matched for coal mining, productive without creating the maneuvering constraints of larger machines. In copper and gold mining, where material is more challenging, the D11's ripper capability is critically important. Ripping material before dozing is necessary, and the D11's weight and ripper force are adequate for many hard rock requirements. In the intermediate hardness range, material too hard for dozing but fragments with ripping, the D11 makes the operation viable. In large civil projects like dams and airports, the D11 provides the force needed for earth-moving phases before precise grading. Its CAT grade system allows rough grading with more precision, reducing the work needed from smaller, less productive machines. The deployment of D11s in the oil sands of Alberta represents one of the most challenging industrial applications. The abrasive material places extreme demands on the undercarriage. Track life is shorter and maintenance intensity is higher. Operations manage this through optimized maintenance, enhanced wear packages on the blade, and techniques that minimize wear-intensive movements. The D11T2's performance has made it a standard specification for oil sands mine development and production. CAT's support network and the machine's record have maintained its market position against all competitors. The Caterpillar D11 has been the standard large bulldozer for more than 50 years. Not because it was always the largest, not because it was always the most powerful, but because it was always the most reliable and the best supported machine in its class. The D11T2 is a fundamentally different machine from the D11 that was introduced in the early 1970s. It has a different engine, different transmission, electronic systems, blade design, and undercarriage. But the architecture, the philosophy, is continuous. The same commitment to reliability over novelty, the same investment in service network and parts availability, the same discipline of continuous improvement guided by field experience. The future of the D11 will follow the same pattern. Autonomous capability, building on the grade and slope foundation to develop fully autonomous operation, is an active development focus. Electrification, the transition from diesel to battery electric or hydrogen fuel cell power, is a longer horizon development Caterpillar is pursuing. And continued electronic integration, more sophisticated fleet management, and better predictive maintenance will extend the productivity advantages. Whatever those future developments bring, the D11 will be at or near the top of the large bulldozer category. Engineering discipline and market infrastructure sustained its dominance. 50 years of accumulated trust is the most durable competitive advantage. The Cat D11, the standard for 50 years, for good reason. Next, we move to a machine that approaches the bulldozer function from a different engineering tradition. The Liebherr PR776. The largest bulldozer in Liebherr's range reflects Swiss-German engineering culture, precision, quality, and an advanced hydraulic system design. This produces a different driving character, a machine that competes with the D11 in many of the same applications. Its specific engineering choices produce performance advantages where Liebherr's design philosophy is most fully expressed. The engineering comparison is fascinating, and we are just getting started.